Okay, lesson 2 over interval notation. And we're going to use interval notation to describe graphs that we're looking at on coordinate planes and number lines. But with interval notation and inequalities, we're looking at relations that are continuous. So instead of a graph with, you know, a bunch of separate points, with interval notation or with continuous functions, we're talking about, lines and stuff that's continuous. So it's made up of infinitely many points that are all connected. Okay, that's what we're talking about by continuous. Okay. Yeah, you can't list individual points because there's infinitely many. There's far too many, but infinitely many. It never stops. Okay. So continuous functions, linear, that's like a line. So f of x equals x. And if you've seen the equation of a line before, you remember like y equals mx plus b. Well, m would be here for the slope, plus b gives you your y-intercept. But the parent function is just f of x equals x. For a quadratic, we're talking f of x equals x squared. So a line, quadratic, something, that type of shape if you've seen it. Absolute value, which looks similar to the quadratic, but it comes to a point. And for cubic, we have x cubed. And those look something like that. Okay, so to describe what's happening with your graph, we've got these symbols, inequality symbols, like less than or equal to, less than, greater than or equal to. With what we're going to be dealing with here, describing domain and range, we're always going from least to greatest. So we're going to be using less than or equal to or less than. When it's less than or equal to, you use a bracket with interval notation. If it's just the less than, you use parentheses. And on a number line, the less than or equal to in the bracket corresponds to a closed dot. The parentheses and less than, just regular less than, corresponds to an open dot. Or if a line actually passes through, it doesn't have to have a dot. Usually you'll just see the dots at the end if it doesn't continue and it ends at a certain value. So if the line goes through that value, then it would be like this one up here, less than or equal to. Okay. So for interval notation here, it's saying that it does include the a and the b because it's less than or equal to. Okay. And this, you could have seen it, they could have done it as a solid dot on each end. Okay, just so you know how they see it. Down here, it would have been a circle. So the way we write this, it does include a, and it starts from a. A is our minimum, and it goes all the way up to a maximum b. And it does include b, so we use a bracket. Down here, it does not include a. So it gets as close as it can to a, but never actually touches it, and it goes all the way up to b as close as it can get and never actually touches it. So down here, it does include the a, but does not include the b. Okay. So I think y'all get the idea here. On this one, you got an arrow. It just keeps going and never stops. So that means it's going out to infinity. And we always use a parentheses because remember this, the bracket, that all means that it can equal this value. Well, infinity is not a number, so you can't say that it equals infinity because infinity is a concept, meaning that it just keeps going. Okay, so there's nothing for it to equal. It just means that it keeps going. So always use parentheses with infinity. And when you're inputting infinity into the homework in Canvas, you just use two lowercase o's side by side. Okay, so this one does include a and goes out to infinity. Looks like they forgot the arrow there on those. So this one starts at negative infinity, or comes from negative infinity, and goes all the way up to b, but does not include it. This one comes from negative infinity, goes up to b, and does include it. Okay, so now we can use that to state what our domain and range is. So our domain is horizontal, all of our x values. So all the x values here that are in this graph. So the smallest x value is here at -2, and the biggest x value is here at +2, and the graph covers every x value in between. Okay, so even though the graph's moving vertically also, when we're describing the range, we're just saying the x values in the graph. The range is just the y values in the graph. So what I like to do is, okay, so the line goes through -2. So closed dot or bracket, however you want to draw, it's fine. And now from left to right, least to greatest, draw a number line and don't pick up your pen until it stops here. Okay, so this graph doesn't go any further to the right than 2. So -2 over to 2, and it does include the 2. So if you were doing the brackets, it would look like that. Okay. So for an inequality or set builder notation, it's going to look like x, straight line, and now you just write your inequality. Okay. So your minimum, it goes from -2 less than or equal to, because it does include the -2. So -2 less than or equal to x, because we're saying all the x values in this graph, is less than or equal to +2. Okay. Interval notation, that would look like bracket -2 minimum to +2 maximum bracket, because it includes both. Okay. Range, same thing, just going vertically. So closed dot or bracket if you want a bracket, and least to greatest, draw your number line until the graph stops. It stops here at +2. Okay, and that way if you prefer dots. And we're from -2 up to +2. So our range in set builder notation with using the inequalities looks the same as our domain. Just remember, we're talking about the y's now and not the x's. interval notation, bracket, -2 to 2, bracket. Is this a function? Well, we can use our y-axis as a vertical line and see that it hits the graph in two places. Okay, and with the vertical line test, if it touches the graph in two places using a vertical line, no, it is not a function. Okay, here, least to greatest for our domain, we start at -4 with this open circle. Horizontally, draw your number line until it stops here at +3. Okay. And so our domain is from -4 less than, because it does not include the -4, x, which is less than or equal to 3. So that. And in interval notation, parentheses, from -4 to +3, bracket. Our range is, it starts here at -5, goes up to -3, and does include the -3. So we go -5 is less than, y is less than or equal to -3. And that is parentheses, -5, comma, -3, bracket in interval notation. And yes, this one is a function. So vertical line is only going to intersect this graph in one place, no matter where you draw the vertical line. Okay, more practice. Our domain, we're dealing with horizontal x values, okay? So open circle is as far to the left as we can get it here at -3. Draw your number line until the graph stops or there's a break. It stops here at +1 with a closed circle, okay? So -3 is less than x is less than or equal to 1. Interval notation, parentheses, -3, +1, bracket. Range. It goes all the way down here to -4 and does include it. It includes it in two places. So even if this closed dot wasn't here at the end of the line or the curve does go through -4 at this relative minimum here. Okay. And least to greatest till it stops at 0. Okay. So -4 up to 0. Less than or equal to y, which is less than 0. So bracket -4, comma 0, parentheses. And if you draw a vertical line all the way through, test every part of this graph, it only hits it once. So yes, it is a function. Okay, this one here, this -4, so there's a line where x equals -4, okay? We call that an asymptote because the graph that we're looking at on both sides gets as close as it can to that -4 but doesn't touch it. So it's like an invisible barrier where the graph stops and picks up on the other side of it. That's the vocabulary term for that is asymptote. Okay, but just remember it's this invisible border that the graph is on both sides but doesn't touch that border at -4. Okay, so if we do the same thing, and there should be arrows here because these go on. So we start with an arrow at coming from -infinity, and we draw our line until there's a break. Well, there's a break right here where x is -4. And then it starts up on the other side and goes out to infinity from there. Okay, so domain, it's coming from infinity, -infinity. And less than, not or equal to, because nothing equals -infinity. It's a concept. -infinity is less than x, which is less than -4, and -4 is less than x is less than positive infinity. Okay, so in interval notation, that looks a little different, but all we're doing is adding a U, which stands for union, but you can just think of it as and. Okay. So -infinity up to -4, not including it, and U means and -4 on out to positive infinity. Okay. Our range. Okay, starting from the bottom, we got an arrow, so we're coming from -infinity. And same thing, we have a horizontal asymptote. So the -4 is our vertical asymptote, and when y is 0, that's our horizontal asymptote. So we have an open circle break at y is 0, and then it goes on out to positive infinity. So -infinity is less than 0, is less than y is less than 0. And 0 is less than y is less than positive infinity. Interval notation, parentheses, -infinity up to 0, parentheses, and parentheses 0 out to positive infinity, parentheses. And if you take a vertical line, it's never going to intersect this graph more than once, okay? No matter where you draw that vertical line, it's only hitting it once. So yes, this is a function. And one more page. Sorry, I thought that was the last one. Real quick, this is probably common sense for a lot of you guys and gals, etc. But if the function is going up, the function is increasing on that interval. If it's going down, it's decreasing on that interval. If it's not going up or down and it's staying constant or the same horizontally, then the function is said to be constant on that interval. Okay, so here our increasing intervals, looks like we just have one. Okay, so increasing, we're looking from left to right, and we're looking to see if it's going down, staying the same, or going up. Okay, so if it's going down, even though we're going left to right and we're looking at it, the graph, if it's decreasing, notice the y values are getting smaller. If it's constant, the y value stays the same. If it's increasing, the y values are getting bigger. But we're looking at it from left to right. Okay, so increasing, it's going up here to here. Even though, yes, it's at a little bit different rate that it's going up at that point, it goes up from 2 over to 4. And we use open circles when we're talking about these intervals that are connected like this, because it's not increasing or decreasing at this point. Okay, that's the transition point. So we call that a relative maximum when it's a peak. And if this were flipped and it was a valley, then it would be a relative minimum. So that's why we do not include that point when we're talking about increasing and decreasing in constant intervals. Okay, so we go from 2 to 4 is where we're increasing. I'm just going to write interval notation, parentheses 2 comma 4 comma, or 2 comma 4 parentheses, and that's our only increasing. Okay, increasing. For decreasing, let's go ahead and start. Just get in the habit of going left to right. Okay. Let's go ahead and make that a closed dot. It doesn't have a closed or an open dot, so let's just go ahead and close those so it's not confusing for anyone. Okay, this interval here, we're going down from left to right. Okay, so we're decreasing, and we're decreasing from where x is 0 over to x is 1. Close circle because of it including this and it being an endpoint. Okay, here we use open circle because we're also going to talk about it in this interval. Okay, so since it's part of both intervals, we're using the open circle. So we've got decreasing here between those 2 points, it's constant. And then from here to our endpoint that's closed, we're decreasing again. Okay, so this first decreasing interval, it decreases from 0 to 1. So since it does include the 0, bracket 0, comma 1 parentheses, and parentheses 4, because it's decreasing from 4 to 6. Bracket on the 6 because it's the endpoint and does include that. Okay, and our constant interval is right here between where x equals 1 and 2. Okay, and parentheses on both of those for the same reasons we already stated. Okay, that's it. Take a look at the homework. Bring me your questions. See y'all later.